So, good evening. I'm Warren. I work with Patrick in the Maxit application team. And today I'm going to talk about refactoring or Gloria code smells. So, yeah, what exactly is refactoring? Refactoring is basically a disciplined exercise where you look at your code, you see that, okay, there's parts of it that can be better. You try to improve the internal structure of your code such that its external behavior doesn't change. And what I mean is, you look at your code, there are parts that you feel could be written better, could move better, could flow better. Try to do things like these without actually changing the output of your software. Why? It's to make your code more understandable. And why exactly, I'll get into more details. It makes your code easier to extend. Like, the more a developer can look at code and say that, okay, like this is how it flows. That makes it easier for a developer to actually go in there and create a complex solution much quicker. And so yeah, William Opdyke, he was one of the first guys who actually went into the science of refactoring. And this was earlier in the 90s, where he had a talk at AT&T Bell. And he spoke for about 45 minutes and he asked people that, what do you think about the state of code? Like, these are the things that we need to change, very aggressive about all of these things. He went in there and he said the current state of technology is way ahead of what we are doing. And everyone was like, okay, dude, stuff works, why should we change it? And I think a lot of us see things like this even in our daily lives. I mean, as developers, you approach someone and you go to them and you say that, oh, look, these are the things that we can change and blah, blah. So how do you actually convey this to someone? Is refactoring actually worth it? What are we trying to do with refactoring? We're trying to increase the readability of code. From a developer's perspective, this is very important. You look at code, to understand it and to change it, to maintain it, you need to understand what the code actually means. Like, you should be able to read it. Refactoring is an exercise where you go through your code, you change parts of it, make it more readable. And it goes hand in hand that when your code is more readable, it's more maintainable. And when I say maintainable, this means it is also scalable. When I say scalable, I mean tomorrow someone wants to add a new feature to your code. Extend it. It becomes easier when you know it in and out, and you know how it flows in and out, and you're not waiting to actually think, okay, I've got to analyze this, I've got to see where this is going, okay, there are complex flows. I don't really know where it's going. More readable equals more scalable, right? So, kind of, if your code is readable, be happy, otherwise refactor it. It's complex programming. So, in his studies, William Opdyke went and he was like, okay, there are two major blocks to people actually approaching code and going like, okay, I want to refactor this. Developers do not want to refactor their code. Why exactly? Usually a developer does not want to revisit code, especially when it's one of these situations. He had a new project. There was no backward compatibility at the time that he was given his requirements. He had all the requirements the first time he got it. And he completely understood the problem the first time. All of these things happen every single day. They know that they were under scheduled, which of course never happens. They were asked to extend code that they didn't fully understand. And the other side of the twofold block was actually that the management never really saw the need to. Why? And a lot of people will agree to disagree on this, but I feel it's the onus of this is actually on the development side, where the development side should actually go to the management and say that, look, there are parts of the code which I feel should change, and do it. And you have to kind of go and explain. So it all reaches this entire state, which I call perfect coordination. And it's pretty well explained by the Simpsons, honestly, because the Simpsons have basically done everything, including refactoring. So here's a developer going to Mr. Burns and saying that, look, here's a door, this door is the product, and all these tiny little things are the parts of the code. And here's what happens when you jam too many features into the code. perfect coordination, right? And Mr. Burns goes, so there can't be any more bugs. And he's like, no, 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 even the smallest change could actually, and Mr. Burns goes, no more bugs. Right? So it all comes down to when a developer is working with his code. So when you look at code, you get a problem. A pattern is a commonly occurring solution to a problem. And this is what you aim to get. An anti-pattern is a solution that has negative consequences. Something that you look at something, you're under scheduled, you have less experience in the field, you try to fix that small thing. And that particular small thing, tomorrow, maybe day after tomorrow, maybe 10 years down the line, will break. So it's kind of easier to get things done quickly as compared to actually getting them right. So this is what causes a lot of bad stuff to get into your code. And yeah, a lot of people ask me why the smells and whatnot. So that's actually a technical term. Code smells are, as the author of the book, Refactoring, puts it, as long as you can name something, when you name something and you can identify it, it makes it easier to fix it. You can when you can quantify something, when you can say that, okay, this is a problem, this is a smell, then you can actually go forward and say that, okay, these smells exist, this is how I can quantify it, and this is how I can fix it. So getting down to the various code smells that are actually documented, there's a lot more, of course. So some of these, duplicate code. So I've seen this a bunch of places, honestly, in a code, in some of the code bases that we've been working on. This happens when a lot of people work together in separate teams, sometimes across continents, when different people are actually working at the same thing. You see people have implemented solutions using their own thought process without actually looking to see whether or not there have been solutions already. So duplicate code exists in a lot of places. Why is this bad? This is bad because a lot of times we see our solutions don't stick. You see it working in one page, you don't see it working in the other page. So it's very hard as a developer to always keep track of these things, which is why it's important for us to get into a refactoring exercise where we look for certain things like this, extract such things. So the solution for something like duplicate code is, you find them, you extract it, you put it into one class, you try to unify the method, you pull it up into a superclass, and make it centralized. You try to remove as many instances of duplicate code as you can. The large class or the God class, so the large methods. Again, it's very dependent on the solution that you're working on. A lot of times developers say that the best methods are never over 15 lines, which, to be honest, in our code, I've seen things that go up to 500. So at times, it's very important to understand a class and see what it's responsible for. A class being a container for code. Suppose you have a container that says, I'm going to take care of all of red. Let it do only the things that red are supposed to do. The solution, again, to something like this is to extract things that are common, responsibilities that are common, and pull them and keep them into one class. Divergent changes. So divergent changes are basically classes that are on their way to becoming large classes or God classes. So as a product is evolving, as more and more people are getting into it, more and more people are fixing, there's new things getting in, there's more things being pushed in, there are chances that your existing containers are going to grow out of proportion. And slowly there are things that are being added into it that were not initially planned to be the responsibility of a class. The idea is, again, to break this and try and keep every container and let it do only the things that it is supposed to. Now, shotgun surgery. So this, although it sounds kind of violent and my pain skills are, all I found was Arnold Schwarzenegger. Honestly. So I decided to draw it. So shotgun surgery is basically when you're working with bug fixes, right? When you're trying to fix something or you're trying to extend something, some bit of your code, you say that, okay, fine, this is the class that I'm actually supposed to change it. You run it, it breaks. Why? You have to change it somewhere else. Fine, do it there. You run it, it breaks again. You find that you're supposed to change it somewhere else. This is kind of a code smell that is indicative that a particular change, just to make it stick, you have to basically perform shotgun surgery. You've got to fire out of the shotgun and change multiple places in tiny bits and pieces. So again, the idea is extract most of these divergent changes or shotgun changes, pull them into a class that actually holds them together. The long parameter or primitive obsession, so this is kind of more a newer methodology where methods sometimes get very complex, and to call each method you have a certain method call. Now suppose you have a library which says that, fine, there are these 4 particular things. When you look at the method call, you actually know what it is. It's an integer, it's a boolean, it's a cost, it's a float. So when you're trying to fix your code, you're going to the place that calls the method. And the method for that is 1, 2, false, 0, 0, probably null. You have no idea what those parameters mean unless you actually dig deeper and deeper and deeper. The idea is encapsulation. Get your parameters into a class container, create a class object which actually knows and creates good getters and setters, so that the moment you have to call a method, you set it accordingly. You know exactly what you're setting and what you're sending, which makes it easier for someone else to read it, which makes it easier for someone else to extend it. Conditional overflow is again one of those things that you see in code that is evolving. It keeps evolving, it keeps changing. More and more people are putting more and more conditional statements, like if or else or switch statements, and they keep growing, they keep growing. And at times, you don't even know if half of these things are valid anymore. It's important that we revisit conditional overflow. When you look at large, complex if-else statements, go back to it, look at it, probably take out some. It makes it, again, the entire idea is to make your code more and more readable. The more readable it is, the more scalable, the more maintainable. Inappropriate intimacy, yeah, it sounds kind of weird, but so it's kind of like a fighting couple in general. You have 2 containers, they're fighting with each other, and they both want the blue. And there's continuous method calls between the 2 of them. So inappropriate intimacy basically means high coupling between 2 of your methods or 2 of your classes. And you want to extract these things out. And just like in a sticky divorce, get a lawyer. So let him keep the blue. Right? So there's also a couple
kind of like
of
no means no, right?
Yeah.
Oh boy.
So speculative generality and dead code. These 2 are pretty close to each other. Speculative generality means a developer's working on a particular piece of code. He looks at it and he's like, okay, I know of this fantastic new thing that we can add, and let's just leave it there. That is someone thinking that maybe in the future you'll use it, maybe you'll never use it. Maybe people thought it was a good idea and put it there, but never actually used it. Things like these, along with dead code. Dead code, again, is one of those things where at some point in a product, during its evolution, we decided that we will do something like this. So I think the best way to explain this is, how many of you think we are going back to DB2? How many of you think that that code is required right now? That is speculative generality right there. You don't want the code right now. You're creating dependencies into your internal structure right now, because tomorrow you may move to DB2. So it's kind of one of those things, and again, it's one of those things where we think we have version controlling. the entire idea of version controlling is that you can always go back to something that you had. At times, it's good. Again, all of these things have to be measured. They're not like a tomorrow, okay, this guy said he had a refactoring talk, let's take out all of DB2. No, it's not like that. You take your time with this. It's an exercise that's done over time, right? So, yeah. So the solutions to code smells in general, again, like you name your problems, you name your solutions. You extract things into a new method, you extract things into a new class. You unify them into a method whenever you get a chance. You use meaningful variables. I can't stress on how important that is. Int x is probably the most widely used parameter in the world. You can use inheritance and pull things that are duplicate or something of that sort up into the parent. Sometimes when you feel a particular method is not required in a parent, push it down to a child, isolate it there. Create an object when you feel the parameter is too long, or you feel a particular method is using too many primitives. And see a method, yeah, obviously that's like dead code. Get it out of there. Right? So, yeah. That's, yeah, just like a quick recap for all of them. If you guys have any questions, let me know.
So you talk about creating an object if you have too many parameters. How do you know when it's too long?
Again, it always depends on what kind of a solution you're making. It depends on how large volume, large scale an application you're talking about, what your processing power is behind. You don't want to create too many objects where, suppose you're creating a mobile app and you're creating too many objects. Then you're creating a lot of overhead processing. In terms of compile time or runtime, you're creating more objects, it's going to create more of an overhead. But when you're talking about a large-scale application, which actually has that, say, 5 minutes or 10 minutes allowed, and it's going to process for like 10, maybe 5 or 6 hours later, where in an application like that, you can afford those few seconds. So it kind of depends. You've always got to weigh what your application is meant to do versus what you are aiming to do, right?
So you said refactoring is changing the internals of your method, right? So if you take something that's 500 lines long and you start pulling things up, and right, what's the overall risk to doing that, and how do you deal with it?
So one of the major things that refactoring as an exercise is that, again, this goes hand in hand with what we are going to follow up with very soon, which I will get to, unit testing. Unit testing is, again, one of those intrinsic things that you need to have in your code. And as a software development practice, whenever you refactor, you do not go and say that I want to change the entire code base tomorrow. You do it in bits, you do it in parts. You do it in small testable modules in such a way that as it grows, it becomes easier and quicker to test these. There is a lot of risk involved, yes, but if it is tested correctly, both at the level of a developer and at QA. So if you have these two walls that are actually moving, that are actually stopping things from breaking apart or changing the behavior of your product, I think it's a controlled risk.
So refactoring with unit testing, as opposed to just
yes.
refactoring without unit testing, is really rewriting your code with no clue.
With no clue of what you're doing. Exactly. Yep.
So which begs the question of here, right? How much we do unit testing?
That's why Laurent is going to talk about that.
So Laurent is doing the unit testing.
Cool.
The next.
So yeah, at times it's also important to understand when you don't refactor. So it's all good to say that, fine, we're going to change everything about the code. But sometimes the code is genuinely broken, and you don't want to sit there fixing something that might take months to try and refactor and actually get into a working condition versus simply rewriting it. an example of this was, I think, the recent caper that we had with Apex, where there was a module that was written years ago for top letters, which someone wrote, no one could understand. Everyone kept banging their heads and trying to, figure out something or the other. Where when you spend months and months over a bit of code just to get it working for version 1, it's sometimes better to revisit the design than to revisit the code itself. Right? When the deadlines are close and bug fixes, both of these are very close to each other. You don't want to have major refactoring done when you're working with close or really hard deadlines. You don't want to do it with a bug fix where you're supposed to turn it around within a day or so. You want to do it probably when you have a larger scale product, or as a larger scale project where you're adding an entire feature that is touching multiple sections of your product, or you want to do it at a time where, okay, there's a window for development to do a certain exercise that can improve quality. That's where you actually go for it. And sometimes there's basically no reason to, but it's always better to at least analyze before the conclusion is made that, okay, don't refactor. Again, we're looking at readability, maintainability, and scalability. Readability for the developers, and as you go down that ladder, you're reaching scalability, which is actually the best for the organization. And to further answer Eric's question, how do you stop it? No, of course not. Code review. That's one of them. So code review is one of the ways that you can stop bad code from actually getting in. So like the picture says, the lesser the people cursing around you after you've submitted your code, the better it is. So bad code, many
But there's
more people
always somebody
cursing.
cursing. Is that what that means?
Yeah.
Usually, yes.
So this goes back to our code review SciTalk, and learning that we don't do it everywhere.
Yeah.
That's how they are appreciating us.
Right? And the next one will be unit testing. And that's why so again, both of these exercises go hand in hand. They actually, it's important not to conduct something without the other. It's like two sides of a coin or whatever. So yeah, cool. That's it up.
Thank you.
Good.
Thank you.